exist that are solutions. So now let's take a look at the other approach, which is the substitution technique. Substitution method. And let's start with some examples, and I'll illustrate through examples what I mean by that. Say, for example, I have this one equation over here. Y is equal to 2x minus 3. And I have another one, say y is equal to 5x subtracting 7. And I want to solve it. Now I could graph that and see if I can find the solution. What you do find, however, when you do things graphically, it's really hard to get fractions as the fractions. So it's okay to integer values like the last problem I had, but more often than not, you have fractions as solutions, a crazy decimal solution, so it doesn't always work. So what do I do? Well, this is the substitution technique. Here's my first equation, here's my second equation. What I'm going to do is, doesn't matter, look, I'm going to take the second equation. So in this second equation it says y is equal to that. So I'm going to substitute for y what it's equal to in the second equation into the first. So I'm going to substitute for y in equation 2 into equation 1. So that's what I'm going to do. I'm going to replace y with 5x minus 7. So y is equal to 2x minus 3. So now I have a single equation of a single variable. So I can solve this for x. Okay, so I could subtract 2x from both sides. So going through, that would give me 3x minus 7 is equal to negative 3. And I divide both, so add 7 to both sides. So I'd end up with 3x is equal to 7 minus 3 is 4. Or x, in this case, is equal to 4/3. So that's one solution. I get x is equal to 4/3. I'm not done yet. I know what my x value is. Now I have to find the y value. So what do? Once I found the x, then I go back to this equation. So I now substitute for x in this equation over here, and that'll tell me the associated y coordinate. So I plug that in. So I get y is equal to 5, and x over here is just equal to 4/3, so it's 5 times 4/3 minus 7. So now what do I have to do? I have to do all of the algebra over here, the arithmetic. So this is equal to y is 20/3 minus 7. Well, for 7, I'm going to create that and turn that into thirds as well. That's 20 minus 21. That gives me y is 20/3 minus 21/3, which is equal to a negative 1/3. So I have my solution, which is x is equal to 4/3, y is equal to negative 1/3. Now, you might be able to do this graphically. If you had a really good graph paper, you could recognize a third, 1 1/3 and minus 1/3, possibly do it, but I wouldn't want to even chance it that you get something close. But that's the solution method. You take for one variable in one equation and substitute into another equation. Let me do another one. I'm going to do 3 of them, and then I'll have you attempt to do some. These are all linear, so we're not even having any problem. But we're going to see later on in the chapter, the same approach will apply to nonlinear systems of equations, which are much more complicated. But understand, because it will help you later on in this chapter. Here's another example. Say I had, y is minus 3x plus 5, and say this is x is equal to minus 2y plus 7. So here are my two equations, given in a different way. Well, since this one is solved for x, what I might do is substitute for x in this equation. It doesn't matter what I substitute for. So I could take this for x and substitute for x in the first equation. So doing so, I would get y is equal to a negative 3 times x. Okay, x in terms of y is negative 2y plus 7 plus 5. Okay, carry this through. Solve that, in this case now, for y. Take that first equation and solve for y. I'll do it quickly in my head and see if we get the same answer. So I got 16/5. Everyone else getting that, hopefully? Anyone want to see how I got that? Hopefully I did it correctly. I'm doing it in my head. So. Okay, let's just do this. Carry it through. Do it on the side over here. Multiply through. Y is negative 3 times negative 2 gives me a positive 6y. Negative 3 times 7 is negative 21 plus 5. So y is equal to 6y minus 16. Okay, let's subtract 6y from both sides. I get negative 5y is equal to a negative 16. Divide both sides by negative 5. And I get y is equal to 16/5. Now you should be able to do this sort of algebra. Practice doing that because that will hinder you throughout. Okay, now I know y. Not the no pun intended there, not the y. But now I need to find x. So I take this for y in here and I substitute it in over there. So do that. Do that and see if you can find what the x is. So substitute for y in this equation to find the x coordinate associated with that. And I'll do this again in my head. Minus 32. And I should get this. So I get 16/5 and 3/5. Again, that's something I probably would not want to do using graphing techniques. That's why this is a much more useful approach. Does anyone want to see how I got 3/5 there? Anyone comfortable with that? Anyone getting 3/5? Check me because I'll do it in my head to make sure I did it correctly. Everyone's comfortable with that. Okay, those are two examples. So my final answer, x is 3/5, y is 16/5. And that would be where those two graphs intersected, if you will. Now what happens if I get something like this? Let's take a look at another example over here. Leave that one up here. Take a look at another example. Okay. So I have these two equations over here. So what can I do? Let's turn it around. I have the first equation solved for y. Doesn't matter. I've been going from the second and into the first. It doesn't have to be that way. I could take this over here and replace it for y over there. So when I do that, let's see what happens over here. So let's do that over here. I'll do 2. Y is equal to 4x minus 1. Make sure you include the parentheses. Be careful here. Minus 8x is equal to 3. Okay, multiply through over here, and I end up with 8x minus 2 minus 8x equals 3. Well, what happens to the x terms? They cancel each other out. They're gone. They were gone. Then I get this crazy result, this thing that cannot happen. I get negative 2 is equal to 3. Well, we know negative 2 does not equal to 3. What happens? Well, it turns out that this is an inconsistent system. These are two parallel non-intersecting lines. And I tried to force them by plugging this in. I tried to force them to intersect. And it gave me garbage out. So anytime you get a contradiction over here, then the answer is no solution. It's an inconsistent system. You get an inconsistent result. No solution. Now, what if I just change that very slightly? Instead of this having to be a 3 over here, I just had this to be a negative 2. So instead of this result, I had equal to a negative 2. Then what would have happened? Well, I would have gotten everything over here. I would have gotten negative 2 on the left-hand side is equal to negative 2. This is a consistent system, and it's always true. In this case, what you would say, this is a dependent solution. It's consistent, and you have infinitely many solutions, and they are essentially every point on this line, meaning these two equations were just multiples of each other. And that's why I did it in my head to make them that way. Y is equal to 4x minus 1. So given an x, tell me the y, and that will solve this system. They're just the same equation. So this is consistent. You get something that is a consistent result, meaning they are dependent. Infinitely many solutions given by, I could solve either one of those for y or solve them for x if I so chose, and I would get that answer. So that's how those the three cases will manifest themselves when you're doing this non-graphing technique. In the first problems, I got a unique solution. In this case, I get a crazy thing. My variables in both of these, the variable vanishes. The x is gone. And in one case, I get this contradiction, which is an inconsistent result, meaning no solution. But in this other case, I get everything is equal. So it's consistent, so it's dependent. So again, we're back to the three possibilities, as I mentioned at the beginning. You have either, unique solution, no solution, it's inconsistent, or they're the same line, so it's consistent, and they're the same, if you will, line. So the other two problems I work with this first one here is this, and this one is that. Possible outcomes. I wanted to show you how they manifest themselves. Okay, that being said, let me give you some to try now. And that's what we'll end with. No new material, just practice solving these systems by substitution. And again, you should be comfortable with the graphing techniques. If not, practice out a little bit. Make sure you are. Some people are overly dependent upon their calculators. It's not a good thing to be that. Calculator is a great tool, but don't be overly dependent upon it. Make sure you can do things without it. So try some of these. Solve each of these systems. Let us apple them. Try those three and see how well you can do. Use the method of substitution. Don't graph them, just substitution. Let's kind of bring it over here and see what we get. Keep me awake. So we get -2, -10. I'm going to do this in my head over here. Doing that in my head, see if I can get any problems over here. So I kind of worked problem 1. Hopefully everyone sees how to do that. 2 I did in my head, so I either could have made a mistake there. Does anyone want to see me work through problem 2? Problem 1, I took my 4x minus 2, plugged it in over here, did the algebra, 3x subtracting 4x is minus x Then take negative of negative is plus 2, and then I simply, oh, it's positive 2. Ooh, excuse me there. Oh, no, it's negative. It's just x has a negative in front of it. Keep going with what I did. Don't try and add a minus x is equal to a positive 2 or x is negative 2. Okay, let's take a look at this one. I'll get rid of this graph over here, and we'll see what we're going to do to solve that. See if I got it correct in my head. So first step over here, I'm going to, since this is solved for x, I'll replace the x over there in that equation. So it gives me 2 times x over there, which is 2 minus y. That's why. All right, so minus 3y. So minus 3y is equal to 7. So I made that substitution into that second equation. Made a mistake there. So these are off. What happens when I do them inside my head? So they're going to be off. Wasn't carrying one of the coefficients. Distribute that, so I'm going to get 4 subtracting 2y minus 3y is 7. So I get 4 subtracting 5y is 7. Then I subtract it, so I get negative 5y is equal to 3. I had it 4. Dividing that, I get y is equal to a negative 3/5. Okay, so I now have what y is. What can I do? Well, now that I know what y is, I can go back into this equation here and find out what x is. So I get x now is equal to 2 minus, well, the y I just found is a negative 3/5. So that gives me x then is equal to 2 plus 3/5. So I'm subtracting a negative. 2 is equal to 10/5. So I can rewrite this as x is equal to 10/5 plus 3/5 or 13/5. Add a 4 instead of a 3 there. That's my mistake. So my solutions are x then is equal to 13/5. So the answer, x is 13/5 and y is negative 3/5. And that's a unique solution. So that worked out easily. This one, I got no solution. Anyone want me to show you how that works out? So let's, this is, no. This should be infinitely many solutions. Again, I'm doing this in my head. I'm looking at that right now. This has infinitely many solutions. That's what it should be. It is consistent. Okay, with that change, anyone want to see that? I'm working in my head real quick. Okay, so let's see how that works out. Let me clear out some space over here. And we'll do that one. So I need to solve one of those equations for one of the variables. It doesn't matter how I do this. What I could do is let's transform this equation here simply by, well, I could just solve this for x. I'm going to solve this for x. This is equivalent to x is equal to 3y plus 4. I just moved the 3y over. Okay. Then I'm going to substitute for this x in that equation. So that's what I'm going to do over here. So I have my 6y minus 2 times x is 3y plus 4 is equal to a negative 8. Okay, so let's distribute everything over here. So it gives me 6y minus 2 times 3 gives me 6y, negative 2 times 4 gives me negative 8 is equal to a negative 8. Notice what happens. The variable vanishes. And what do I end with? I end up with the consistent statement that negative 8 is negative 8. When that happens, it's not inconsistent, then these are dependent equations. They're actually the same equations. So we have infinite many solutions. And what do they look like? Well, notice what I could have done over here. If I wanted to, I simply could have take that second equation and divide every term over here by a -2. So I divide this by a -2, that by a -2. I'm dividing both sides by a -2. So what does this give me? This gives me -3y plus x equal to 4. Well, notice, flip these around and they're the same equations. So my solution, I could take any one of those if I wanted to and say my solution is any points that satisfy this equation is my solution. That's my solution set. Just grab one of the equations and grab it, and those are where those two lines intersect. They're overlapping lines. They're coincident lines. They both fall right on top of one another. Okay, so that's the system of substitution, solving a system using substitution. Practice this, because we will be looking at this later on when we look at the more complicated things of nonlinear systems. This is the go-to technique for that, and you will need to know how to do that when you get to the calculus. These are linear systems, and then you also look at nonlinear systems later on. Okay, so we looked at two techniques. Now, I'll end, just kind of mention, you could also do it if you had 3 equations. There's a problem there if you have 3 equations. See if you can figure that out on your own. We'll go over that tomorrow if you cannot. But for example, you could have x minus y minus 2z is equal to 4. 2x plus 3y is equal to 5. Say plus z is equal to 5, and minus x minus y minus z is equal to, say, a positive, or plus z is equal to a positive 4. This cell has 3 equations. So what could you do? Well, what I could do is I could solve the first equation for x. X is equal to y plus 2z plus 4, and substitute that into these other 2 equations. Okay. Then I'm going to have 2 equations that are just going to be y's and z's. Solve one of those for a y or z and substitute into the other one. This is the harder one. There's one problem at the end of this, 2 problems at the end of the section for 3 equations. See if you can figure out how to do that. If you can't, it doesn't mean you're not going to pass the course. It just means your skills